Hello viewers, looking for a video that gives you complete detail on gravitational potential, its definition, equipotential surfaces. Not only that, it also solves a past paper question for you, so don't worry, we got you covered. 10 marks guaranteed. Watch the entire video and solve the past paper questions yourself.
We have already read W is equal to mg and that the gravitational potential energy is equal to mass times gravity times height in the Earth's gravity. Value of gravity is taken to be 9.81 meter per second square, also rounded off to 10 meter per second square. This gravity is also known as gravitational field strength. When it comes to strength, then the unit of gravity is equal to Newton per kg from the formula W is equal to mg. If we make g the subject, it will be equal to W over m. And the units will become Newton per kg because units of W are weight are Newton. Coming on to gravitational potential, the symbol for gravitational potential is capital V or phi. And its definition is that at any point in the gravitational field, work done to bring a unit mass from infinity to that point is called gravitational potential of that body. And its units are joule per kg. The gravitational potential is assumed to be zero at infinity. The diagram is shown on next page. A mass is shown, capital M, and it has been shown that there is infinity in the line of the center of the mass, where whole of the mass seems to be concentrated, and an object is moved to point P from infinity. So the force will have to be applied on the object, and distance will also be moved. So work will be done, and if we talk about the equation of the gravitational potential, it is equal to negative of gm over r. At surface of Earth, it is going to be minus gme over re, where m is mass of Earth and re is radius of Earth. This formula has been derived earlier in this chapter, and I have given you the link for that. Coming on to the surface of the Earth or surface of this mass whose radius is r, the potential will be equal to minus gm over r, and it is true for all objects or bodies. Next heading is gravitational potential energy. Gravitational potential energy is the product of the potential and the mass, so it will be equal to V multiplied by m, and is also available in the data sheet of exam paper at pages 2, 3 and 4. If we talk about 1 kg mass, then the gravitational potential energy is equal to the gravitational potential. Now coming on to equipotential surfaces. If you look at the diagram on the right, an object of mass m is shown and 3 radii are shown, r1, r2 and r3. Because gravitational potential is dependent on reciprocal of the radius, as g and m are constants, so at one radius from the center of the body, the potential will be constant, and if you have a circle drawn at that radius, at all points in that circle the potential will be same, and we will say this is an equipotential surface. I have shown a green, a red and a blue equipotential surface. Topics of the chapter of universal gravitation have been completed. Now we are going to do a past paper question. The past paper question requires us to calculate the radius of the orbit of a stationary satellite, and the data given is in the question. You can read the question. Now, if we have to work out the geostationary satellite, in which the formula which is to be used has already been taught to you in topics of the chapter. The formula is that capital G, capital M is equal to R cube omega square, where capital G is universal gravitational constant and its value is 6.67 into 10 power minus 11. Capital M is the mass of the object whose potential or in whose gravity the satellite is to be launched. Now, in this case, it is Earth, so mass of Earth is 6 into 10 power 24 kg. Radius we have to calculate, and omega is the circular speed, but here omega is not given, so we are going to work out in terms of time period, because we know that omega is equal to 2 pi over t. So going on to step 1, we make r cube the subject of formula, then we take the cube root of the r on left side and cube root of the remaining part of the equation on the right side. So we have finally r is equal to gm divided by 2 pi over t whole square raised to the power 1 over 3. Now we put in the values, and after having putting in the values and taking the cube root we use in the calculator, we find the radius of the orbit equal to 4.2 10 power 7 meter. This was to be shown. Question asked us to show that the radius of orbit is 4.2 into 10 power 7 meter. This is a 3 marks question, so you didn't have to write everything that I have written, but you could have shown step 1, step 2 and step 3. I have written in red color, and you would have scored the 3 marks. Part B is for 4 marks. So you have to do all that I have done in this. You see, if you have to calculate the change in potential while the satellite is taken from the Earth's surface to its orbit, then the change in potential will be final potential minus initial potential. Final potential will be in the orbit and initial potential at the surface. So in the orbit, we'll take small r, and on the Earth's surface, we are going to take capital R. Then in the next step, I have taken gm as common outside the bracket, and then put in the values of gm and the radius, which we have already calculated in part A, radius of orbit of the satellite, and then we are going to put in the radius of the Earth and calculate and write down the answer. You see, you have to do all these steps because this is a 4 mark part, and you will have to do these steps to for full marks. After having calculated the change in potential, we have to work out change in potential energy and we know that potential energy is equal to potential multiplied by mass. Mass has been given as 650 kg. So putting in the values, I calculate 3.45 into 10 power 10 joules as change in potential energy of the satellite when it is taken from Earth's surface to its orbit. Part C is only for 1 mark, and you have to comment only. And he is asking why the satellite is being launched in the direction of the Earth's spin. It is because that the satellite will already be traveling in the direction of Earth, will be having momentum already, so it will be easy to give the satellite its required speed. And that's all for today. Kindly like and subscribe my channel. Thank you very much.